Two newspapers report on the exact same study. One headline reads, "Daily bacon raises your risk of bowel cancer by 18%. The other reads, "Bacon's cancer risk is tiny. Enjoy your breakfast." Same study, same data, same researchers. And yet, in a strange way, both headlines are telling the truth. That should bother you. Because if two opposite-sounding claims can both come from one honest study, then reading the headline tells you almost nothing about what the study actually found. And most of us make real decisions, what to eat, what to fear, what to buy, based on exactly these headlines. Here's the good news. The reason this happens isn't some deep conspiracy or advanced statistics. It comes down to a handful of predictable traps and how findings get translated into words. Once you can see the traps, they stop working on you. You don't need a science degree. You need a way of reading. So here's what this video will give you. First, the single most important shift in how you think about what a study even is, because if you get this wrong, everything after it looks like nitpicking. Second, the three specific traps that let one finding fool you: mistaking correlation for cause, the trick of relative versus absolute risk, and the danger of trusting a single study. And third, a simple three-question checklist you can run on any health headline you'll ever see again. Let's go in order. What a study actually is. The root of almost every misunderstanding is one hidden assumption. We treat a study like a courtroom verdict: guilty or not guilty, true or false, safe or dangerous. The headline says coffee is bad for you, and we file it under settled fact. Next month, the headline says coffee is good for you, and we throw up our hands and decide scientists can't make up their minds. But a study was never a verdict. A study is a measurement. And like every measurement, it comes with two parts that the headline almost always throws away. The first part is the estimate, the best guess at the size of an effect. Not just coffee affects health, but in this group, coffee drinkers had, say, a 9% lower rate of this outcome, a direction and a size. The second part is the uncertainty, how much that guess might be off. Think about what a study actually does. It can't test every human on Earth, so it takes a sample, a few thousand people, and uses them to estimate what's true for everyone. But your particular few thousand people are partly a matter of luck. Grab a different few thousand, and you'd get a slightly different number. So a good study doesn't just report one figure. It reports a range. It's fairly confident the truth lives inside. Scientists call it a confidence interval. You can just think of it as the error bar, the wiggle room around the guess. Here's why this reframing matters so much. Once you see that every result is an estimate with a range attached, three things follow naturally. A study can be perfectly honest and still land on a number that's a bit off. That's not a scandal. That's how sampling works. Two studies can disagree slightly and both be fine because their ranges overlap. And a single number ripped out of the headline, with no range and no context, is missing the very thing that tells you how seriously to take it. There's one more piece. Every study answers a narrow question, not a grand one. It doesn't test, is coffee healthy? It tests something specific. This many cups, in this kind of person, measured this way, over this many years, for this one outcome. When the headline widens that into coffee is good for you, it has quietly promoted a narrow finding into a universal law. So hold this lens for everything that follows. A study estimates the size of an effect, with a margin of error, for a specific question, not a verdict. With that in place, the three traps aren't nitpicking. They're just the practical skill of reading the estimate correctly. Let's take them one at a time. Trap 1. Correlation is not causation. You'll read that people who eat more of some food have less heart disease. The unspoken leap your brain makes is instant. The food protects the heart. Feels obvious. But that link, that correlation, can be produced by at least three completely different situations, and only one of them means the food is actually doing anything. The first is the hidden third factor. Scientists call it confounding, and it's the big one. Imagine a study finds that people who drink red wine have healthier hearts. Tempting to conclude the wine helps, but who tends to drink a moderate glass of wine with dinner? Often people with more money, less physical stress, better health care, better diets overall. That whole bundle, call it wealth and lifestyle, is the hidden third factor. It's pushing up wine drinking and pushing up heart health at the same time. The wine and the healthy heart travel together, but neither one is causing the other. A lurking variable behind both is creating the link. Here's a cleaner way to feel it. In summer, ice cream sales rise and drownings rise. They're strongly correlated. Nobody thinks ice cream drowns people. The hidden third factor is heat. Hot weather drives both. Confounding in health studies is the same shape, just harder to spot, because the hidden factor is usually something tangled like how health-conscious a person is. And health-conscious people do 100 good things at once. Untangling which one mattered is genuinely hard. The second situation is reverse causation. The link is real, but the arrow points the other way. A study finds people who exercise less are more likely to be in poor health. Easy to read that as not exercising ruins your health. But flip it. Maybe people who are already unwell, in pain, low on energy, in early stages of disease, exercise less because they're sick. The illness reduces the exercise, not the other way around. Same correlation, opposite cause. The third is plain chance. Measure enough things, and some will line up by pure luck, the way you can flip a coin and get 5 heads in a row without the coin being rigged. If researchers test a food against 20 different diseases, the odds are decent that at least one link shows up just by accident. That's why a lone, surprising correlation, especially one nobody predicted in advance, deserves a raised eyebrow, not a headline. Now, none of this means correlation is worthless. Correlation is often the first clue that something's worth investigating. The point is narrower and more useful. An observed link by itself cannot tell you which of these 4 things you're looking at: a real cause, a hidden third factor, a reversed arrow, or luck. So whenever a study is observational, meaning researchers watched what people already do rather than assigning them to do it, the honest phrasing is associated with, is linked to. When a headline swaps that for causes, it has made a leap the study did not make. Trap 2. Relative versus absolute risk. This next trap is the engine behind our bacon headlines, and it's the sneakiest because nobody has to lie for it to work. Suppose a study finds that eating processed meat every day raises the risk of a certain cancer by 50%. 50%. That sounds enormous, like a coin flip's worth of doom in every sandwich. That number is the relative risk. It tells you how much the risk changed compared to where it started, and that's exactly the problem. It never tells you where it started. Let's put a floor under it. Suppose that out of 100 people who never eat processed meat too, develop this cancer over their lifetime. That's the baseline, the absolute starting risk. Now the daily meat group has a risk that's 50% higher. 50% higher than 2 is 3. So the honest picture is, it moved from about 2 people in 100 to about 3 in 100. 1 extra case per 100 people. Notice that both descriptions are true, of the same result. Raises risk by 50%. True. Raises risk from 2 in 100 to 3 in 100. Also true. That's the whole trick. The relative number sounds like a catastrophe. The absolute number sounds like something you'd weigh calmly against how much you enjoy the food. Same finding. Opposite feeling. And now you can see how one study spawned our 2 headlines. One paper quoted the relative figure, the other quoted the absolute one. Neither lied. Here's why relative risk gets used so often. It produces the bigger, more clickable number, and it's the same regardless of how rare the disease is. But that's precisely what makes it misleading on its own. A 50% increase on a common risk is a real public health concern. The identical 50% increase on an extremely rare risk is almost nothing in practical terms, because half of vanishingly small is still vanishingly small. So the rule is simple. Whenever you see a percentage increase or decrease in risk, your next thought should be, increase from what to what? A relative risk with no baseline attached is a number designed to feel important without telling you whether it is. Find the absolute numbers, the so many per 100 or per 1,000, and the real size of the thing snaps into focus. Trap 3. One study never decides. The final trap is the most human one. A single study lands, the press releases fire, and for a week we treat one result as if the matter is now closed. But go back to our very first idea. A study is an estimate with a margin of error, which means any single study can land on a number that's simply off. Not through fraud, just through the ordinary luck of which people happen to be in the sample. That's not a flaw you can eliminate. It's built into measuring a big world with a small sample. So the fix isn't to find one perfect study. The fix is repetition. If a finding is real, then when different teams with different people in different countries using different methods all look for it, they should keep finding roughly the same thing. That's replication. And when their results point the same direction, even though their methods differ, that's consistency. Consistency is powerful precisely because different studies have different flaws. If a result survives across all of them, it's unlikely that the same accident happened every time. This is the difference between a fluke and a fact. A fluke shows up once and then evaporates when others try to reproduce it. A real effect keeps showing up. So the question that separates a strong claim from a shaky one isn't, was there a study? There's a study for almost everything. It's, do many independent studies agree? This also explains something that used to look like chaos. Remember the whiplash? Coffee's bad, coffee's good, back and forth for years. Seen through this lens, that's not scientists flip-flopping. That's you watching individual data points arrive one at a time, each reported as if it were the final word. Zoom out far enough, and a stable overall picture usually emerges from the noise, which is why the most trustworthy summaries are the ones that pool many studies together rather than chasing the newest one. The practical takeaway needs no deep dive into the machinery of how those summaries get built. Just this, be far more confident in a body of evidence than in a single headline. When a report breathlessly announces, a new study finds, the calm question is whether it fits what the rest of the research already shows, or whether it's one lonely dot that the next study will erase. Your 3-question checklist. Everything so far collapses into 3 questions you can literally count on your fingers. Run them on any health claim you meet, and you've done most of the work of a careful reader. Question 1. Is this correlation or cause? Ask whether the study simply watched what people already did or actually tested a change. If it's an observational link, pause on the hidden third factor. Could something like overall lifestyle be driving both sides? Could the arrow run backwards? Could it be chance? If the headline says causes but the study only watched, mentally downgrade it to is linked to. Question 2. Relative or absolute? When you hear a percentage, 50% more, 30% less, refuse to react until you know the baseline. From what to what? In real numbers per 100 or per 1,000 people? If you can't find the absolute figures, treat the scary percentage as unfinished information, not as a fact. Question 3. One study or many? Ask whether this is a single fresh result or something many independent studies have found again and again. Confidence should track replication and consistency, not novelty. A lone study is a clue. A pile of agreeing studies is knowledge. Correlation or cause. Relative or absolute. One study or many. 3 questions, mapped exactly onto the 3 traps. Come back to where we started. 1 study, 2 opposite headlines, both true. Now you can dismantle it. One headline leaned on the scary relative number. The other used the calm, absolute one. That's trap 2. If the study only observed eaters rather than assigning diets, neither headline should say causes. That's trap 1. And whether you should worry at all depends on what the wider body of research shows. Not on this one paper. That's trap 3. The confusion was never in the data. It was in the translation. And you can now do the translating yourself. None of this makes you cynical about science. It makes you fluent in it. A study isn't a verdict handed down to be believed or dismissed. It's a single careful estimate, with a margin of error, answering one narrow question, waiting to be confirmed by others. Read it that way, and headlines lose their grip on you. One natural next step, if you want to go further, you'll often see the phrase randomized controlled trial, treated as the gold standard for actually proving cause. It's worth understanding why that particular design cuts straight through the correlation trap, but that's a clean topic on its own, and this checklist already carries you through the vast majority of what you'll read. For now, 3 questions. That's enough to stop any single headline from fooling you. Thanks for watching. If you like health claims explained with the reasoning and the citations behind them, consider subscribing to Wise-Cited. The papers are always linked below, so you can check the sources yourself. And there's plenty more here to keep exploring whenever you're curious.